Okay, so now we're going to talk about propositions, right? So representations can be in a propositional form, right? And so I'm going to show some evidence to talk one experiment to show that indeed we probably do represent sentences, or at least some way that resembles a propositional representation. So imagine if the sentence is the geese crossed the horizon as the wind shuffled the clouds. This can be formally defined as two propositions, right? So there's the geese crossed the horizon and then the wind shuffled the clouds, right? So it's two propositions, two separate propositions. And if a sentence, so one prediction, right, is that, or one idea is assumption, I guess, is that if a sentence is represented as two propositions, then only concepts belonging to the same proposition should facilitate priming or processing of each other. In other words, um, concepts within a proposition should prime each other more so than concepts in different propositions. And this is a reasonable assumption, right? If concepts prime related concepts, then a concept should prime a concept in the same proposition more than it would prime a concept from a different proposition. So I actually asked ChatGPT to give a network representation of how it would represent that sentence, and this is what it produced, right? So we can depict a proposition in terms of a network of concepts, each of which is linked by relations. So um, and you can see that this is one separate proposition: geese crossed horizon and wind shuffled the clouds. They're connected. They are connected, but they are sort of also separate. So it may be easier to think of this like, this is the geese concept, right? And it gets activated whenever you read the word or hear the word geese. And so, um, if that activation, one idea is that if the activation, when it gets activated, that activation spreads to related or nearby units or nodes that represent those concepts. So if you think of geese, right, geese will get activated and then it'll spread to crossed and then it'll spread to horizon, right? That will take X amount of time, right, for the activation from geese to spread it to horizon. However, if you read the word wind, right, now the wind unit or node gets activated, uh, and it has more space. That activation needs to spread to a longer distance, right? Either it needs to spread to, so if you hear wind or read wind, it'll take longer for that activation to reach horizon, um, which means that it will take less time for horizon to get activated following the presentation of geese, whereas it'll take more time for horizon to be activated when you read or hear the word wind. Okay. Um, so in this study, the study is to look and see whether sentences can be represented, whether humans represent sentences as propositions. So participants in this study would read a number of sentences, right? So the geese crossed the horizon as the wind shuffled the clouds. And then they were given a recognition test. So they were given words, either words that were from study, so old words, or they were given new words. And so they had to say whether the word was from study or not. Uh, and so the researchers only really cared about how long the reaction time to say that horizon was recognized. So this is like the target word. So it's reaction time to the target word horizon to say yes to the word horizon, to say yes that it was studied. So, um, Yeah. And yeah, so the researchers measured response time to correctly recognize previously seen target words. In this case, the target word would be horizon. Importantly, on the trial that preceded the target word, participants were shown a word that had been part of the same proposition as the target word. In this case, it would be geese, or the word was part of a different proposition, right? Wind, right? And of course, both of these were from the same sentence, but the geese and her was geese concept or geese word was in the same proposition as horizon, whereas the uh, wind concept was not in the same proposition as horizon. And the prediction here is that horizon should be correctly responded to or recognized faster when preceded by geese than by wind. And that's because the geese, activation of geese on this trial should spread to horizon faster, meaning you should then recognize horizon on the next trial faster because the activation has spread to horizon, whereas it'll take longer for wind, the activation from wind to spread to horizon because it's not part of the same proposition. And indeed, that's exactly what they found. So yeah, it took less time to recognize horizon when it had been preceded by geese, the same proposition, compared to when it had been preceded by wind, which was in the different proposition. So this is taken as evidence that sentences are stored as propositions. Okay, I guess we'll stop there in the next video we'll talk about dual coding theory.